Hi students, this is Mr. Yao. Today we are going to talk about 6.c, where we are going to put everything that we have learned about angles with a circle together and do some bigger problems. So let's have a look at example 1. Diameter AB. Oh, actually that's a typo. It should be diameter AC. So my suggestion would always be, as soon as you get a piece of information from the question, start doing some labeling about angles. So if I know AC is a diameter, I would know this side of the arc is 180 degrees. I would also know this side of the arc is 180 degrees, and this angle CBA is an interior angle that is facing a semicircle, so that would have to be a 90-degree angle. And along with that, I would also know about this angle 1. Because angle 1 is actually formed by the tangent line and this diameter, which means it's going to be half of this arc. So angle 1 is going to be 90 degrees, right here. Next, tangent AD. Well, that's kind of together, the same piece of information. Keep moving. Arc BC is 74 degrees. Arc BC is right here, 74 degrees. And as soon as I know about that being 74 degrees, I'm actually going to use a different color. 74 degrees from this piece of information. I would also know this central angle is 74 degrees. So I would also know angle 5 is 74 degrees. Then not only would I know about the central angle, I would also know about this angle CAB, because that is facing this arc of 74 degrees. That's an inscribed angle that's facing the arc. So angle 2 would be 37 degrees. And as soon as I know that is 37 degrees, because I already know this angle CBA is a 90 degree, I would easily be able to find out what angle 6 is. Because inside this triangle, I already know the 37 degrees, I already know the 90 degree. So my angle 6 would have to be the other angle inside that same triangle. So 180 minus 90 minus the 37 degrees, that's going to give you 53 degrees. And if I know angle 6 is 53 degrees, something else you would need to know, these are all radii. So that means we have a bunch of isosceles triangles. So since OC and OB are the same, that means angle 6 and angle 7 would be the same. So now I would also know angle 7 is a 53 degrees. Then since angle 2 is 37 degrees, I would also know angle 8 is a 37 degree as well. Now that I know the angle 2 and angle 8, inside this triangle, I can find out about angle 4. That's one way. Or I can use this straight line. Since I know angle 5, I would know angle 4 is going to be 180 degrees minus the 74 degrees, which is going to be 106 degrees. 106 degrees. So now let's see. I have 1, 2, I don't have 3, 4, 5, 6, 7, 8. And that's almost everything. Now I just need to find out about angle 3. So angle 3 is formed by this tangent line and this chord AB. And this arc right here, AB, or arc AB, is actually in there. So angle 3 is going to be half of the arc AB, the measure of arc AB, which is basically the central angle. So it's going to be a half of the 106 degrees, which is 53 degrees. That's one way to find it. Or you can just do 180 degrees minus the 37 degrees minus the 90 degrees, because this angle and the 2 and the 1 together is 180 degrees. That would also give you 53 degrees. And now I found everything. So that is example 1. Moving on, example 2. Angle 1 is 22 degrees. Arc AD is 57 degrees. It is asking to find about angle 2. If you look at this question, we have learned about angle outside a circle. That is related to the arc is formed. So clearly it's going to be related to AD and BC. I'm just going to write that down. So arc BC minus arc AD, which is 57 degrees, is going to, and half of that is going to give you 22 degrees. Now let's have a look at what the angle that we're trying to find. Angle 2 is an angle inside a circle, so we need the angle that is facing this angle and this vertical angle. So clearly that's a 57 degree. And arc BC again. That means I do need to find arc BC first. So multiply both sides by a 2. Arc BC minus 57 degrees is going to give you 44 degrees. So that means arc BC is going to be 101 degrees. Now I can easily find out about angle 2. The measure of angle 2 is going to be a half of 57 degrees plus 101 degrees because these are the two that's facing. And since it's inside a circle, we are going to add these two arcs. That is going to be half of 158, which is 79 degrees for angle 2. And that is example 2. Moving on, example 3. Angle 1 is 6x minus 1. Well, let's label it 6x minus 1. Arc RS is 5x minus 2. Arc QT is 5x plus 12. Well, that's kind of the same situation. This angle and the vertical angle are facing the 5x minus 2 and the 5x plus 12. So that means 6x minus 1 is going to be a half of the arcs added together. Half of 5x minus 2 plus 5x plus 12. So 6x minus 1 equals to half of 10x plus 10. You can choose to distribute first, or you can choose to multiply both sides by a 2. Either way, 6x minus 1 is going to be 5x plus 5. Move the x over, move the 1 over, so that means my x is going to be a 6. But I'm not fully done. It's also asking about arc RS. So arc RS is going to be 5x minus 2, so it's 5 times 6 minus 2, which is going to be 28 degrees. And, well, we can always put it back in to check. Angle 1, in this case, if we put it back in, 6, that's going to be 36 minus 1, so 35 degrees. Arc RS, we found is 28 degrees. And QT, we found it to be 5 times 630 plus 12, which is 42 degrees. And these two added together, 70, which is twice of our angle 1. That is example 3.